This video is brought to you by ASRock. Yes, thank you ASRock. And the Z490 Tai-Chi 10th generation Intel Core processors have been announced, and this motherboard supports the 10th generation processors that have been announced. But this motherboard was tested by us with the 10900K and the 10600K. Now, ASRock has done some really interesting things with this motherboard. So first up, you got the 10th generation CPU support, which of course means that you're going to have insane massive power delivery. That's Dr. Moss. 60 amp power choke, 60 amp power delivery. And you may be thinking, wait, didn't I see this kind of power delivery subsystem on an extremely high-end motherboard? And you would be correct. Yes, indeed you did. Yes, because this motherboard can deliver a whole bunch of power. And also Nahimic Audio. Nahimic Audio is a high-end audio solution. It's a high-end implementation of the Realtek ALC 1220 for nice, clean, powerful amplification to be able to drive those studio headphones or whatever it is that you might be plugging into it. So if you're considering building a computer based around Intel's 10th generation core CPUs, you should check out the Z490 Tai-Chi, link below. I did the video on setting up RAID with Ubuntu 20.04. Congratulations again on the launch of Ubuntu 20.04, guys. It's really awesome. This video is about Arch Linux, but setting up something similar. You got 4 M.2 NVMe on some kind of carrier card. It's vaguely similar to the Liquid HHHL, but I gave Greg Cora Hartman my Liquid HHHL. And of course he uses Arch Linux, and so we set up a RAID array with his HHHL. But the question came up during the build, is Linux MD faster, or should we use LVM's built-in RAID? And these kind of cards, like I've got the ASRock Ultra Quad M.2 here. Some motherboards even come with add-in cards like this where you can, RAID together a bunch of M.2. AMD supports that with their proprietary driver. Of course, that doesn't work on Linux, but you can do it with software on Linux. And so I thought I would give you a little write-up and a little commentary on the Arch Wiki on the stuff that's there and how all that works. Let's dive in. But what could you possibly offer that the Arch Wiki doesn't offer? Haha, comprehension. It seems overwhelmingly complicated when you first look at it and you start to dive into the diagrams, but the thing to remember is you need an EFI partition, and you ideally need a boot partition. And when we're talking about encryption, you can encrypt the boot partition or you cannot encrypt the boot partition. And you can put the EFI partition and the boot partition on another device. So, in everything that we're talking about, know that you need an EFI partition and a boot partition. Those don't have to be on the same device. They can be on different devices. I've got 4 NVMe to work with. We'll talk about it, but the EFI partition and the boot partition ideally makes your life easier. It's not hard and fast in every scenario you have to have a boot partition, but it makes your life easier having a boot partition. With all of the rest of the space that's available, because, with an EFI partition and a boot partition, those aren't real big. 500 megs is what I've set up on my system here. The rest of the space is just how you combine it. That's all that the complication is. So when we're talking about encryption, you can encrypt the rest of each physical device, which is a physical partition if you've got an EFI partition and a boot partition. Or you can set up LVM and you can say, hey, these are the physical slices of each device that are going to be managed by LVM. And then inside that, you can create encrypted volumes, or you can create a volume that is then encrypted. So you have either of those options that are discussed in the Arch Wiki. What we're going to do here is use LVM to do the RAID type functionality, where I can say, hey, we've got 4 slices of 4 different disks. That is most of the storage on the disk, except for the EFI and the boot partition. It's basically the entire disk. So that's going to be managed by LVM, and then inside that I'm going to create 1 or more volumes which are optionally encrypted. And that's sort of the mindset that you have to be at. But let's take a look at the Arch Wiki diagram. So this is a little strange looking, the table here, and I think it's a little misleading. You got LVM logical volumes /var/swap home, and then volume groups /dev/vol group array, and then RAID arrays dev md0 and dev md1. So they're setting up swap as a RAID 1 of all of the drives, which will give you 4 times the read performance, but the same write performance. I think a RAID 0 for swap would be my choice. Unless something has changed dramatically in the last 10 years, with swap, you could just create 4 partitions on the underlying physical disks. So if they're saying that SD SDA2 and SDB2 and SDC2 are the partitions that comprise swap. You would just swap on MK swap and swap on SDC1, SDC2, SDB2, SDC2 for your swap, unless you want to encrypt your swap, which is a different thing, but you could, and it's not a bad idea to encrypt your swap, because you never know what's going to make it to swap. So the swap functionality will take care of striping reads and writes however it needs to across a single device, and there wouldn't really be any point in redundantly writing whatever has been written to swap to multiple disks. So, and the heading says, many tutorials treat the swap space differently, either by creating a separate RAID 1 array or LVM logical volume. Creating a swap space on an array is not intended to provide additional redundancy, but instead to prevent a corrupt swap space from rendering the system inoperable, which is more likely to happen when the swap space is located on the same partition as the root directory. More likely to happen in the same partition as the root directory. That. If trout live in trees, it will not rain. Just make a partition, or 2 or 3 or 4. A little bit of swap, and MK swap on those partitions, and call it a day. Unless you need encryption, and we'll come back to that. So for the how-to that's on the level 1 forum, the main recommendation from me is to use Linux MD to create the array of partitions on your physical devices. And it's up to you to choose if you want RAID 5 or RAID 6 or whatever, and then create your LVM volume group on that device, and then create the logical volumes inside that volume group. Now, that also means that we will have a separate boot partition, which is just an ordinary ext4 partition, and we'll also have an ordinary EFI partition. Now, with multiple devices, with like 4 devices like this, I will cheat a little bit and create, say, a 500 megabyte slice at the beginning of each device. And so like the very first device in the system, that'll be my EFI partition, and I will format it accordingly. Then on the next device, its 500 megabyte partition will be boot. Now, if I want redundancy, I can also just copy those partitions, like manually set it up, because things don't change a whole bunch on those. Manually set up the same partition structure on the other 2 NVMe and copy everything over. So if I need an extra EFI partition or an extra boot partition, I've got 2 more 500 meg partitions that I can use. If I want swap, you don't really need a lot of swap. You shouldn't have 0 swap. You could create a swap file that's very small. But depending on what you're doing, you probably don't need a lot of swap. And if you have a lot of swap and you're constantly using a lot of swap, it's probably going to wear out your SSDs prematurely. But if you want to, like these are 512 gigabytes, you could create a 1 gigabyte partition for swap as the next partition. So you'd have 4 gigabytes total. I wouldn't want to wait on a system that is more than 4 to 8 gigabytes into swap anyway. That would be a note to my future self. Hey, you should probably buy more RAM for your system. And then so the next partition, which would be the balance of space on these devices, would be the partitions for Linux MD. Now, if you don't want to use Linux MD and you just want to use a pure LVM solution, you can. But that's not covered in the Arch Wiki. If you would prefer to use LVM to do your RAID, all of the work is done with LV create, the same way that you're going to create a logical volume, but it has to do with the types. And Red Hat has the best documentation on this, not the Arch Wiki. And this has been supported since, 6.3, I think 6.3 on the Red Hat side of things. And so it's a little different for me on the Arch side of things. And I actually have more experience doing this on Debian than Arch or Red Hat, so a little fuzzy. But if you want to use LVM, you want to experiment with just LVM, see the LVM section of the how-to on the level 1 forum. So LV create won't let you specify RAID 0, and that kind of makes sense because you get RAID 0 type functionality. Another name for that is striping. So you would have to create a striped logical volume to get RAID 0 type functionality out of LVM. What that basically means is you have your physical devices or your partitions, and you say, hey, LVM, I want you to use these physical devices, and LVM will automatically stripe reads and writes across all those physical devices. So that's kind of built into LVM. Now, let's talk about encryption and LUKS. So I mentioned there's two different versions of LUKS, LUKS v1 and LUKS v2. The whole LUKS v1, v2 thing can sort of catch you off guard. It's like, I'm going to encrypt everything. I wouldn't recommend you encrypt your boot partition. And if you do encrypt your boot partition, you should encrypt it as LUKS v1. And I think I've implied this, but I haven't explicitly stated it. The boot partition / boot should be like ext4, the Linux file system. But then inside that, you have a directory called EFI, which is another mount for your EFI partition. So it's a little weird. The EFI thing is the system the UEFI can read from and starts the boot process, and then the thing that is read into memory and executed from that EFI partition will try to get your initial RAM disk from what is the /boot partition and read your initial RAM disk, and then boot and mount your root file system and optionally a home file system and all that stuff. Your boot partition will probably have to contain keys for decrypting your root partition. Otherwise, you will get asked to decrypt it a second time, because it's like enter your decryption information, and then so Grub will take your password or whatever, decrypt it, and then the initial RAM disk will be able to be read, but then the initial RAM disk needs to decrypt the root partition. So in order to do that, your keys have to be stored in the initial RAM disk, and that's still protected if your boot partition is encrypted. But if your boot partition is not encrypted, and you have your decryption key in there, then that would be a bad situation. Alright, let's go back to our multi-disk array. So I've used Linux MD admin, and I've taken these 4 disks and created one large container. Now with that one large container, I can create a volume group, or I can encrypt it. So if I encrypt it, then you can't really see what's inside it. Or I could create, the volume group and then encrypt a specific volume in the volume group. So that could be multiple keys. Or it could just be one key if you only have one volume. The ArchWiki, under encrypting an entire system, explains this a little bit more. It can do LUKS on LVM, uses dencrypt only after the LVM is set up. LVM, advantages. LVM can be used to have encrypted volumes span multiple disks. Easy mix of unencrypted and encrypted volumes. It's like the disadvantages. It's complex. Changing volumes requires changing encryption mappers too. Volumes require individual keys. LVM layout is transparent when locked. And so you can also do LVM on LUKS. Simple partition knowledge with LVM. Only one key required to unlock all volumes. Easy resume from disk setup. Volume layout not transparent when locked. Easiest method to allow suspending to disk. LVM adds an additional, and then the disadvantages of that are LVM adds an additional mapping layer hook, less useful if a singular volume should receive a separate key. There's also LUKS on a partition, and this diagram on the ArchWiki, again, it's not the best. The first column, boot partition / boot, physically that's on /dev/ada1, and then it's got LUKS2 encrypted partition / dev mapper crypt root. That's physically SDA2, and then optional free space for additional partitions to be set up later. So this might be SDA3. You look at this, and on the EFI side, you actually also have your EFI partition. So this is, perhaps harkening back to the days before EFI style boot. And if you can, you should use the EFI style boot as opposed to BIOS style boot, but I don't want to really get into that just now. Some people, in encountering this complexity, will actually use a USB stick as their boot, and they'll just carry it with them. They'll have the bootloader and their initial RAM disk and the kernel and all of the stuff that they need on a USB stick, and then their computer is, the root partition that's there is physically encrypted. So you plug in a USB stick, you boot off the USB stick, and because the USB stick was only the boot information, there's no performance penalty from doing that. It's just starting up the computer, requires the key to be in ignition, as it were. And it also makes it a lot harder for your computer to be tampered with, because you physically have the USB stick with you that lets you boot, and the rest of what's in the computer is encrypted. So physically, physical access to that is not really going to help somebody, mostly, unless you get really creative. So that's an overview that hopefully will help you conceptually. You have your physical disks. I've got my physical storage here. What's the strategy for combining the storage of the physical disks? And then how am I going to manage optional encryption? And the strategy for combining the physical disks has to do with also redundancy as well as volume management. So I can use Linux MD for redundancy, and then I can use LVM to manage the volume itself and the slices and that kind of thing, or I can use LVM to manage the redundancy and the containers for everything else in a way that partitions doesn't really, because with partitions it's hard to sort of grow a partition and resize things, and it's an operation. So LVM is advantageous if you're adding things, adding storage to the system, adding more and more devices over time, whereas with Linux MD I wouldn't be able to easily add just another physical block device. Like if I got a fifth NVMe that I wanted to add to this, a pure LVM setup is going to be slightly easier to deal with, but you can get yourself into a situation where you've added another NVMe for storage, but you may not have added any extra redundancy. So if that single NVMe dies, you'll lose literally everything. And then ZFS does all of this. It has all of this built in a monolithic kind of a way, but has more overhead as a result. But the overhead is maybe worth it because it's a one-stop shop for dealing with things. But ZFS on root is something Ubuntu 20.04 supports. You can do it with Arch. Wasn't something we were interested in for Greg Carr-Hartman's build because he wants speed. So this was configured for maximum speed, not so much redundancy. He's going to handle backups on his own. But somebody else on the forum asked, after I did the Ubuntu video, hey, is there a way to set up LVM and LUKS with Arch, because I'm having trouble getting my head around it. So I did a little how-to, but I also did a longer video, which hopefully conceptually will get you there. I'm Wendell, this is level 1. This is the level 1 Linux channel. Subscribe and up dude or down dude or whatever, comment. Thank you. Thank you for watching. I'm Wendell. I'm signing out and I'll see you later.